Morning. So today we'll learn about IP addressing. So IPv4. Let's talk about IPv4. You can learn IPv6 later. So let's get into the theoretical part. So if you Google what is IPv4, you'll get a 32-bit address and these things. Okay. So what actually we're gonna do is, this is actually the range is from 0 and then 127. This is actual IP address. So we'll come to this later. So as I said, IPv4 is a 32-bit address. So we're gonna enter 32 bits. So this is 8-bit, 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 and 8-bit. So if you count this, it's 32-bit. So if you take this 8-bit, this will be considered as one octet. So similar, this is one octet, this is one octet, and this is one octet. So total there are 4 octets. So according to classes, we're gonna concentrate more about first octet only. So depending on this, classes are classified. So let's go ahead. So we'll take class A. So in class A, first octet first bit is equal to 0. So we will, as per the theory, we will take the first octet of the class A. So we'll put here, and well, here it is. So if you take here, this is the first octet of class A. So rest another 3 byte are on the other side. So we need to focus on first byte. So if you take the first byte, this is a resource bit. So according to the class A, resource bit is 0. So this will be 0 always. Okay. So and rest will go from 0 0 0 0 0 to 1 1 1. So if you get down, well, here, so you can see here, this is the first octet. So in first octet first bit, this is 0 always. Similarly, this is 0. So rest all we gonna place zeros and to 1. So what we're gonna get is 0 to 127. How are we gonna get this? So every bit is assigned with this number. This is the weightage of first bit, second bit, third bit, fourth bit, fifth bit, sixth bit, seventh bit, eighth bit. Okay. So these things you have to remember. So as I said, we're gonna consider the first byte. This first byte. So I have elongated here. Okay. So if you keep 0 here, this result is won't change, and rest all zeros, and then we're gonna change this everything as 1 except this one. This is the result bit. So if you add zeros, we're gonna get zeros. If it is 0 0 0, we're not gonna add this. We're not gonna count this. And similarly, we cannot come down. If it is 1, we're gonna count this. For example, this is 0 and rest all 1. So we're gonna add 1 plus 2 plus 8 plus 16. Since this is 0, we're gonna add 1 plus 2 plus 8 plus 16 plus 32 plus 64. Since this is 0, we're not gonna add this one. So since this is 1, we're gonna add these things. So 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64, we're gonna get 127. So this is how we classify. This is classified 0 to 127. Okay. So but in theoretical, we got like 1 to 126, right? So if you have googled, you could have got like so 1 to 126. Okay. So why we are not considering 0 to 0 and 127? So the 0 is a network address and 127 is a broadcast address. It will be like little confusing as beginner. So right now, just go ahead on the flow. Later you will come to understand these things. So friends, we're gonna come down and write the class C address. So class A is 0 to 127. We will write this as 0 to 127. I will explain the network and broadcast address later. So, and this is subnet mask. Subnet mask is nothing. Um, Subnet mask. So in class C, subnet box is 255. This is standard. You need to understand that first octet is the network port and rest all the host port. So that's why uh, this is 245. If you place one in every bit, how much you will get? So 1 plus 2 plus 4 plus like that. If you count, you will get 255. Okay, so rest all it will be 0. So this is the host part. So if you are a bit confused, just hold on. You will get to know in a future section. So similarly, uh, please understand this is a class A. So it's first byte is a network part. So we wanna place one in every bit. We will get, if you count everything, we'll get 255 and rest all zeros. So if you count every bit, we'll get 0. So 000. So let's come to class B. So in class B, so first 2 bit from the first byte is zeroed. Yeah. So this is the first octet of the class B. So and here comes less 3 bit. So we'll take the first 2 bit. First 2 bit is resolved. So resolved bit is 1 and 0. So this bit will be 1 and this bit will be 0. So rest on like ranges from 0 to 1. So on the first side it will be 0 and if we come down it will be 1. This won't change. So I will come down a little bit. So as you can see, so first 2 bit are 1 0. So if you take a rest, it's all 0. Similarly, this is the reserve bit, and if you just enter as 1 and count the bit value, you will get 128 to 121. See, this is the 1 2 4 8 16 32 64 128, right? So if you count this, you will get 128, and this all goes like you know a 0. So we are not considering about these things. We only consider the first byte. So similarly, if you count the ones here, so just ignore this. You will count 1 2 4 8 16 32 plus 128. You will get 191. So this is how it ranges, and as I said, as per the standard, first two byte are network portion, and these two byte are host portion. Okay. Similarly, for class C, so if you take the class C address, first 3 bit of first octet are reserved. So let's assume that this is the first octet of the class C. Okay, so these 3 are reserved. One is